Hey guys, welcome to the final review video for Algebra 2. I'm going to attempt to make it through units 1 through 4 in this video. I'm going to move pretty quick through it because this is just meant to be a quick review, not learning it for the first time. I will make a note of which problems are coming from your review and which ones you might want to, or which areas you might want to have on the note sheet at the end. Your reference sheet at the end is the only thing you get to use on your final. All right, here we go. So for Unit 1, the first thing that's going to come up is parallel and perpendicular lines. You need to know that parallel lines look something like this. I think of them like railroad tracks. They are side by side going up at the same rate, so therefore they have the same slope. And I need you to know that that either means that they both have equations like this. Sorry about the bell. So notice how they both have the same number here in the middle. That means both of their lines would be going up to rate 3. So then they would have the same rate, and that's why they would look something like this and be parallel. If you have two perpendicular lines, that is something like this. Or if you rotate that, it looks something like this. Just be careful, these are kind of hard to eyeball if you want to see if they're perfectly perpendicular. This thing right here should be a right angle between 90 degrees. You can also use the corner of a piece of paper if you want to see if that's 90 degrees. Their slopes have to be opposites and reciprocals. Here's what that looks like in an equation. If you have an equation that's y equals 2x plus 4, then the slope in the other equation, since this one's positive, would be negative, and the reciprocal of 2 is 1 over 2. X plus, 7. Again, I'm not really worried about the y-intercept. What I am worried about is that I both flipped the sign and I flipped the fraction. So this one's like 2 over 1, and this one's 1 over 2. You're going to need to be able to identify when two lines are parallel and when they are perpendicular. That's the main goal here. So this is example 1 from the review. Sorry, let me go back. You may want to pause the video here and write some of this for your notes. I would say that this part right here is probably the most important part. Some of the other stuff was just me explaining how it works. So number 1 on the review is we want to graph a line parallel to y equals 3/4 x minus 2 that goes through to 3. That means that my slope of the parallel line is going to be the same slope as I have up there, 3/4. All you have to do is go to the point 2, 3, and then draw a slope of 3/4, up 3 over 4. Like that. And you're done. Okay, take a second to write that down. Okay, I'm also going to draw the next one, except for I don't have it typed up, so I'm going to erase this. And I'm going to get rid of, hopefully, this for a second. Here we go. Okay, so this is example 3 from the review, and it says graph a line perpendicular to y equals 2/3 x minus 1 that goes through the point 1, 5. So a perpendicular slope to this one is going to be negative because it's opposite, and the reciprocal makes it 3/2 instead of 2/3. So we're going to go to the point 1, 5. and we needed to have a slope of -3/2. Remember that that's rise over run. So we're going to rise -3 and run 2. And that's my line. So you're just using this one for its slope. And since it's perpendicular, I have to do the opposite reciprocal, whereas on the last one, I just kept it the same because parallel lines have the same slope. Next up in Unit 1 is absolute value equations and inequalities. Here's what I would add to your notes sheet before you move on to the next section. Absolute value is a distance from 0. And there are 2 different directions you can go from 0, left and right. Left being the negative direction, right being the positive direction. So you're always going to have 2 solutions. Then I would add the fact that an absolute value cannot equal a negative number. Instead of writing all those words out, you might want to write something like this. If you had the absolute value of x equals -4, it can't equal a negative, so this one would be no solution. There is no number that is -4 as a distance from 0 because we don't use negatives when we talk about distance. It's either 4 units away or nothing. There is no number you can take the absolute value of that equals -4. All absolute values end up positive. All right, make sure you pause the video if you don't want me to move on to the next example yet, if you need a second to write those notes. So we have 2 basic operations we're going to do, or goals, when we are solving absolute value equations. Isolate and then split it into plus and minus. It may be worthwhile to write this example on your notes sheet so you have one to look back at. What I mean by isolate is get anything that's outside of the absolute value over to the other side. Six plus 9 is 15. Now, the only thing I have on the left side is the absolute value. That is essentially saying that in this problem, 2x plus 5 is 15 units away from 0. And that can be 15 units to the right, which means it equals positive 15, or 15 units to the left, which means it equals negative 15. But notice how I didn't split it up into the 15 and negative 15 until the absolute value was the only thing on that side. Then I'm solving these both like regular equations. This is the part I'm going to kind of fly through. I need to subtract 5 on both equations. My only difference is that 15 minus 5 is 10, and negative 15 minus 5 is negative 20. Then I need to divide them both by 2, so I get answers of 5 and negative 10. So notice how they solve in the exact same way, it's just you have different numbers on the right side. Let's do an absolute value equation, or inequality next. Make sure you pause the video if you want to get this one written down. For an inequality, you're going to do kind of the same thing. We need 4x minus 6 to be less than 14 away from 0. So let's talk about this for a second. Here's 0, 14 this way, 14 this way. You want it to be somewhere in between. Okay? And that's what 4x minus 6 equals. So either 4x minus 6 is negative 14, or 4x minus 6 is positive 14. And you need it to be somewhere in between the 2 answers for that. So we basically need it to be less than 14 or greater than negative 14. Basically, you just write the same symbol you already had, but when you go to do the negative 14, you have to flip the symbol. That's what that means. So keep this one the exact same. and this one flips when it becomes negative 14. Then for both of them, you're going to add 6 and divide by 4. Oops. And then you're dividing everything by 4. X is either less than 5, and it needs to also be greater than negative 2. What that means is that it is less than 5 because it's pointing to the left, and greater than negative 2 because it's pointing to the right. So that's the middle right there. Write your final answer in interval notation. Notice that I'm using parentheses because these were open circles. If they were closed, I would be using brackets. All right, next up. Systems of equations. There is a way that you can graph them and look where they cross. Know that the solution to a system is the point that they have in common. I don't think you necessarily need to write that down unless you were planning on doing the interview final, and then it might come up as one of the questions. What I'm going to focus on is substitution and elimination. These are two things that you might want to write down in your notes instead of on the rest of your review. Pick whichever one you think makes more sense. So for substitution, you have to get one variable by itself. So I'm going to subtract this 2y to the other side. And I get x equals negative 7 minus 2y. And I'm going to take that and I'm going to plug it in for x, since it's what x equals right here. And then now that I've done that, this turns into just a pretty standard regular equation. I just need to distribute my 4. And leave the plus 6y equals 18 at the end. And then I'm going to get rid of that 28 by adding it to the other side. And I'm going to go ahead and combine my like terms here in the middle. Negative 8y plus 6y is negative 2y. And over here, 18 plus 28 is... Sorry, I missed a negative right there. I was going to say that's not what it's supposed to be. So go back and add a negative with this 18 right here. And that means negative 18 plus 28, which is 10. Then you divide by that negative 2, and y equals negative 5. But a system needs an x equals and a y equals. So in order to find what x equals, you're going to take that negative 5 that you just found, and you're going to plug it into the part that you had substituted originally, right here. Okay. And that becomes negative 7 plus 10, because negative 2 times negative 5 is positive 10, and that ends up being 3. Now let's talk elimination. If substitution is your preferred, you can skip over the elimination part. Elimination is where you want two variables to cancel out. So since the bottom equation is already 4x plus 6y equals negative 18, I'm going to leave it exactly the way it is. But what I need to make happen, I'm going to kind of almost force this to happen, is I want there to be a negative 4x on top, so they add a 0. And what do I need to multiply x by to get negative 4x? Negative 4. So I'm going to multiply that entire equation by negative 4, including the last number, so that now, when I add them together, my x's have opposite numbers, and they will cancel out or eliminate, like this. And then negative 8y plus 6y is negative 2y. 28 minus 18 is 10. Quick note, that's the same thing, guys. We got some of the same work going on because it's the same problem. I'm just showing you how to do it a different way. Then you divide by that negative 2 and you get y equals negative 5. That part of elimination is a little bit easier. You now need to take that negative 5 and plug it into either of the original equations. I am picking the top one. Notice how I've changed the y value to negative 5. That really is x minus 10 equals negative 7. So you add that 10 to the other side, and we'll get that, x equals 3. So for both ways, I got x equals 3 and y equals negative 5. And that, my friends, is unit 1. Now let's talk about unit 2. Unit 2 is matrices. It is worth mentioning in your notes that dimensions go row by column. For adding, they have to be the same size. And for multiplying, the inside dimensions must match. I will show you an example of why that has to be in just a second. Okay, the rest of that is kind of just notes on how you do it. Instead of maybe writing those notes down, I would give yourself an example. Most people find that a little bit easier than just using the words. Okay, pause the video if you need another second to write those down. I am going to do examples 1, 5, 8, and 10 from the review. I have listed the matrices over here on the right. I'm actually going to do the dimensions of all of them. This one has A has 2 rows and 2 columns, so it is 2 by 2. B has 3 rows over here and only 2 columns, so it is a 3 by 2. C has 2 rows by 3 columns, so it is a 2 by 3. Make sure you note the difference between those two. And that's actually questions 1 through 3 on your review. So we actually can't add any of these together because none of them are the exact same size. I'm just going to kind of say that now. What 5 wants you to do is C minus 2b. If we were trying to do this, we would multiply b by 2, which means that you double everything inside of b, or multiply the whole thing by 2. This would be 2b. The issue is you can't do C minus 2b because you're supposed to add terms that are in the same spot. So you should be adding these two, then these two, and then you're out of things. So this is actually undefined because they're not the same size. You should be able to almost overlap the two matrices and add the same parts together. Also, this one has a third row that the part C didn't have. For number 8, A squared means A times A. So I'm going to literally write matrix A times matrix A. Like that. And then when you're multiplying matrices, what you have to do is take this row times this column. 5 times 5 is 25. Negative 2 times negative 2 times negative 1. Put my dot in the wrong spot over there. So I'm basically multiplying these two and these two. and that gives me 2. Then I do the same thing, but with the first row and the second column. And I'm going to do 5 times negative 2. It's negative 10. And negative 2 times 4. And then I have to do the bottom row. Negative 1 times 5. And 4 times negative 1. Negative 1 times 2. Negative 2 is positive 2. And 4 times 4. And then you just add those up. And that is how you multiply matrices. Now let's talk about an example of multiplying matrices that wouldn't work. I'm going to move this down a bit. Let's say you tried to multiply A times B. A, as we said earlier, is a 2 by 2. And B, as we said earlier, is a 3 by 2. So this shouldn't work because these inside dimensions don't match. The easiest way to tell is to try it for a second. If you take this row times this column, there's 2 things over here and 3 numbers over here. So you can multiply these 2 and these 2, but then you get stuck with what in the world to do with that negative 1. That's a multiplication mismatch. That doesn't work. That would be undefined. Okay, and then I'm going to erase this in a second and do the inverse. So if you want to write any of it down, go for it. All right, moving on. So the definition I'm about to do for an inverse is 2 by 2 only. And that's kind of what you can expect on the test, is only a 2 by 2. So what you're going to do is 1 over, and then you're going to subtract the products of the diagonals. So 5 times 4 is 20. Negative 1 times negative 2 is 2. We're going to do 20 minus 2, or 18. Then, for the matrix portion of this, what you're going to do is you're going to flip this diagonal, and for this diagonal, you're going to multiply it by negative 1. So the 4 and the 5 switch places, and the other 2 switch signs. And that is the inverse of A. All right, moving on. Unit 3. So for Unit 3, we have transformations. You're probably going to want to put this in your notes. I'm going to make a little table that says inside, outside, plus, and minus. A plus on the inside makes the graph go to the left. A minus on the inside makes it go to the right. A plus on the outside makes it go up. And a minus on the outside makes it go down. So you might want to pause the video and write that down. And then you might want to write down this equation I have over here, not necessarily the graph, but just this equation. This minus 4 on the inside, minus on the inside goes to the right. So that would be right 4. I'm going to rewrite that because it does not look very good. Then there's a plus 3 on the outside. A plus on the outside makes it go up 3. I'm going to go ahead and put that on my graph just to show you that my first point will be right 4 and up 3. The next thing that you might want to write in your notes is that the original pattern is up 1, left and right 1. And if there is a number in front of the parentheses, you're going to multiply the ups by it. So since I have a negative 2 in front, instead of going up 1, left and right 1, that's now going to be up 1 times negative 2, up negative 2. And to go up negative 2, I'm going back to this point in the middle that I already drew. And I'm going to go down to right 1 and down to left 1. Sorry, I said that backwards. Like that. And that's if it has parentheses. I'm about to switch slides, so go ahead and write that one down or pause the video if you need to. If it does not have parentheses like this one right here, then you have to use a formula. So you may want to add everything that I'm putting over here into your notes. The vertex is negative b over 2a, comma y. And I'll explain a little bit what that means in just a second. For the zeros, you have to factor and set them equal to 0. And for the y-intercept, you plug in x equals 0. You may also want to include all of this part of number 6 on the review, but maybe not the graph because it's hard to draw your own graph. And as long as you have the notes I'm putting at the top, you'll probably be fine. So one thing really quick is that this is A, this is B. A second to chill out. There it goes. Okay, this is B and this is C. Sorry, I know that's not working very well right now. So for negative b over 2a, b is negative 4. So negative 4 is positive 4. A is negative 2. 2 times negative 2 is negative 4. And that divides to be negative 1. Then you take that number and you plug it into the equation for x. And you type that into a calculator. When you type that into a calculator, you end up getting 8. That is your vertex. So for me, that would go left 1, up 8, like that. Then for your zeros, you have to factor. The first thing I see when I'm trying to factor this is that I can divide everything by negative 2. Then I just need two numbers that multiply to negative 3 and add to 2. That's 3 and negative 1. And my zeros are whatever makes them equal 0. So if I want x plus 3 to equal 0, I would subtract the 3. So negative 3 is one of my zeros. And if I wanted x minus 1 to equal 0, I would add the 1. And 1 would be one of my zeros. For my y-intercept, if I plug in 0 for x, all I have left is the 6 at the end. And that will always happen. So then I go put my y-intercept at 6, and my zeros on the x-axis at 1 and negative 3. There's my graph. All right, moving on to the next slide. If you want to pause the video to get this one written down. Okay, I'm going to go ahead and draw a line right here. This part is still Unit 4 on the left. One thing before I get going into this problem that you might want to write on your notes page. I is the square root of -1. It allows us to do things like this. You normally couldn't do the square root of -9 until I is introduced. The square root of 9 is 3. Most of us know that. But since it's the square root of -9, instead of just being 3, it's actually 3i. That is when you would use an I. That's why it exists. If I is the square root of -1, then I squared cancels out that square root, and it's just the -1 without the square root. This one is asking you to multiply it out. 4 minus 3i squared is just 4 minus 3i times itself. You do not simply just square both of those terms. What we're going to do now is FOIL. 4 times 4 is 16. 4 times -3i is -12i. -3 times 4, -3i times 4 is also -12i. And then -3i times -3i is +9. And then I times I is I squared. The middle part is pretty straightforward. -12 and -12 make -24i. But this I squared is -1. That makes this -9. And -9 plus 16 is 7. That's it. And that's why I'm going to pause this video, because this part over here is actually Unit 5. Unit 4, sorry. Actually, I'm just going to keep going with it. So over here we have Unit 4. There we go. This was polynomials. And it just asks you to synthetically divide these two things. This is the one where you have a little box up there, and the opposite of this number goes in that box. Then you list the numbers out front, like that. And the rest of it is an algorithm or just a pattern. This one comes straight down, and this number gets multiplied by this number. That makes 6, and then you add those two together. And then you do 7 times 3, and add -10 and 21. And then you have to write your answer as a quotient. This is always your constant, and then you go up the power of x. And then the one to the next would be x squared, but we don't have a number over there, so we don't actually need it. So my answer is 2x plus 7. And then if you have a remainder, that number is divided by whatever was up here. And that's your answer. Now let's talk about the graphs of a polynomial. It's going to look like this. I'll go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We need to find the zeros. That's going to be coming from here and here. If I want x squared minus 16 to equal 0, I would add that 16 to the other side, and my two answers would be 4 and -4. Okay? So whenever you set it equal to 0 like this, you are finding these x-intercepts. Then, over here, I would subtract the 3. That one's a little bit easier. It's just -3. And to decide how I'm going to draw this, if there is a negative number out here, the right side goes down. If that was a positive 2, the right side would go up like this. But it's not, so we don't need that one. And then it just goes through all of the zeros. So it goes through this one, then it goes through this one, and then it goes through this one. That is the graph of the polynomial. On number 11, anywhere there's an x, you want to set that equal to 0. So we get 0, 4, and negative 2. 0, 4, and negative 2. Since there is a positive 3 out front, my right side goes up. The only other thing that I'm going to say about this line is that since this one was squared, that is a double root, meaning it counts as 2, and it is going to bounce, as we called it. That means that I'm going to go all the way through this one, all the way through this one, but when I get to the negative 2, I'm not going to keep going all the way down. Instead, it bounces back up like this. And that's it. Last thing for Unit 6, it wants you to find the remaining roots. Whatever number it tells you here goes in the box. Since it's already x equals, you do not need to flip the sign. My numbers up front are going to be 1, negative 2, 6, negative 18, and negative 27. And I'm going to use synthetic division the same way I did just a minute ago. Drop this one down. 1 times 3 is 3. Negative 2 plus 3 is 1. 1 times 3 is still 3. 6 plus 3 is 9. 9 times 3 is 27. Negative 18 plus 27 is 9 again. 9 times 3 is still 27. And negative 27 plus 27 is 0. If it says it is a root, this has to be 0. Then, this is our constant. This is our x, x squared, x cubed. We have to factor this to find the rest of them, because the directions for this one say factor to find the remaining zeros. Over here and over here. We've got 2 sets of 2 things. This is called grouping. On this first one, I can take out an x squared. If I take an x squared out of x cubed, I have x left. When I take x squared out of x squared, I have 1 left. Then, over here, I can take out a 9. If I take a 9 out of 9x, I have x left. Take a 9 out of 9, I have 1 left. So my factors are x plus 1, which is the one that matches, and the outside parts, x squared plus 9. Then I set those both equal to 0. And x squared plus 9 equals 0. Subtract that 9 to the other side. And since it's x squared, you have to do the square root. Whenever you do the square root, it's always a plus and minus. The square root of negative 9 is 3i. Sorry, I was going to circle this one, but I didn't have the space. So you have 1, 2, 3i, negative 3i, 3, 4 zeros. Negative 1, 3, 3i, and negative 3i. That should always match the highest exponent or the degree.